Good afternoon, Farmington High School. This is your captain speaking. I got no good lines today, so Unit 2 Notes 4 solving systems using substitution. Some of the things got flipped around as far as substitution and elimination go, 4 and 3. So just make sure you have the right one. Ask me about it. The notes line up, though. All right. We are going to do Unit 2 Notes 4 solving systems by substitution. Here's what we have. We have solved one of the equations for one of the variables. Make sure you know that this means to isolate one variable. So isolate, that means get 7x equal to 7. Okay, you have the x over here by itself before you can divide. Substitute that expression into another equation, solve for the remaining variable, substitute that value into either equation and solve for the remaining variable. I just like to give you the examples. We got to talk about a couple things. Infinite mini solutions. So we did some of this stuff on your eliminations. Let's just talk about it. When you have 0 equals 0, that is an example of a true statement. So then infinite mini solutions are possible. It could be 7 equals 7. Maybe you subtract it first and you have x equals x. Something like that, whenever it's a true statement, then you have infinite mini. So then false would be when there's no solution. So an example of a false statement, I think we had -3 is not equal 6 the other day. 7, I don't know what that is. 7 cannot equal 49. Something like that, then you have no solution. So I'm going to show you some examples here. I think we're doing 6 of them. Right here, this is what we're talking about when it's isolated. Over here is the x by itself. So I know that I can do a couple different things here. I can substitute this whole 2y plus 36 into here for x. Now, one of my colleagues likes to think of it as like a substitute teacher. So if I get a sub someday, I get a substitute, that means that substitution is going to fill in for me. So I would write this as 2y plus 36 plus 2y equals 8. Okay? Yeah, let me rewrite this up here. So this red part here is 2y plus 36. That is the part we substituted. Alright? We got rid of that x. So if I get a substitute, that means I'm absent. Well, if I'm the x, I'm absent. Don't include that anymore. Just include what you substituted, which in this case is 2y plus 36. And now this is algebra. We solve things like this. 2y and 2y are on the same side of the equals. So you just combine those. Alright, now we're subtracting 36, subtracting 36. This goes to 0. 4y equals -32. Divide by 4, divide by 4. Y equals -8. I really got an email at this time of night. Jeepers creepers. Now, for the second part, I have x plus 2y equals 8. You ever had a substitute before? Yeah, we have before. I'm going to substitute this y in here. So x plus 2, my y is -8, so I'm substituting that in. So you've done substitution. We're just doing it now with linear equations. Plus 16, plus 16. I got x equal to 24. Anybody else got that? Where did I screw up? Over here. Okay. You guys aren't here, so you can't correct me. 8 minus 36 is -28. -28 divided by 4 is -7. 4 This is negative 7. This is negative 14. This is negative 14. Plus 14. 8 plus 4 is 22. So my answer is 22, comma, negative 7. Wow. That's a lot. Alright? I'm going to get rid of some of this, so make sure you pause it right now. I'm going to start erasing because I need room. Okay, now over here, I should recognize that it's lined up in standard form, but none of them have the same coefficient, meaning these both don't have 2's here. It'd be nice if it had a negative 2 there. However, I should recognize this x already has the value of 1. So that means I'll just get that x by itself. And to do that, I'll just subtract 2y from both sides. And now my new equation is x equals 15 minus 2y. So I'm going to do that. Trying to figure out what color to use. I'm going to do 2 times the quantity minus 3y equal to 2. So I did that just to recognize this is substituting in for the x. So I'm going to just write 15 minus 2y. Now I have this. 30 minus 4y minus 3y equals 2. Okay. A lot of people are making this mistake on quizzes. Minus 4y minus 3y, or minus 4 yum-yums minus another 3 yum-yums, is at negative 7. Now I got to subtract this 30 and subtract this 30, and I still have negative 28. Divide by negative 7. Divide by negative 7. Y equals 4. Okay, that's cool and all. So now I think I'm going to use this bottom one here. Oh, I'm just going to use this one right here in blue. X equals 15 minus 2, y is equal to 4. X equals 15 minus 8. X is going to equal 7. So I have 7 comma 4. So those would be your 2 first examples of substitution. 3. Ooh, 3 is my favorite. Because really, 3 only has one variable. This x minus 3y is equal to 0. If I add 3y here, and recognize I can get x by itself here, I have x equal to 3y. I think that's by far the best way to do this, because now I'd had 7y equals 26 plus 11x. What am I doing? I'm getting rid of the x variable. So I'm going to get rid of that, and I'll just multiply it by 3y. So 7y equals 26 plus 33y minus 33y. Got to get the y's together on one side, so I got all the y's over here now. 26 equals negative 26y. Divide by that negative 26, and we have a whopping y equals negative 1. So, if I do that, I'm just going to grab this equation again. Okay, x equals 3y, which equals the 3 times negative 1, which equals negative 3. So it's negative 3 comma 1. Whew, that was the best one. Uh-oh. Negative 1. Make sure you have that. Okay, 4 is my second favorite problem. And I'll show you why. What does y equal? Well, in this one it says 3x minus 4, but in this one it says 4 plus x. Either way, 3x minus 4 would equal y. Well, I'm just going to substitute that in for this y. Okay, I can write y equals on any side of the equation, it doesn't matter. But these two statements have to be equal, no matter what you do. Now it's just simple math. Subtract x plus 4 plus 4. 2x equals 8, divide by 2, x equals 4. I'm going to use this bottom one here because I recognize y is already by itself, or I don't have to multiply anything. 4 plus x, well, it's really 4 plus 4 now, so y equals 8. That's been the easiest one so far. There's a couple tricks to the trade, and all of it has to recognize either when you do elimination, you got to recognize what you're multiplying by, and then when you're doing substitution, you just got to recognize what the easiest substitution would be. For number 5, looking at that, it's not lined up at all because the y's are on different sides of the equals for elimination. It's also not really, none of them are single coefficients. However, this bottom one here, 2 goes into all of those. So I could divide all of these by 2. Okay, if I do that, I get x equals 2y plus 2. So I still don't have any fractions. That's what I'm going to substitute back in. So I'm going to write this as 3 times 2y plus 2. Now you see why distributing is so important. Now we're distributing when we sub in. So I have 6y plus 6 minus 6y equals 6. A lot of 6's right now. 6y minus 6y is going to be 0. So I'd really have 0 plus 6 equals 6. And that's going to be 6 equals 6. Right? This is a true statement. And then the other thing you should know is this is all solutions. All values are going to work. It's good we had a problem like that. The second one, number 6. Second one's got a 24. That's a big number. I don't want to deal with that. I do have this y by myself here, over here. So I'm going to do this as 2x. I'm going to subtract 7. So 2x minus 7 equals y. Okay. 2x minus 7 equals y, so I'm going to write this out. 6x minus 3. Now, what equals y? All of this. 2x minus 7 equals 24. Distribute very neatly. I got 6x minus 6x plus 21 equals 24. Combining like terms, you should see that goes to 0, so I have 0 plus 21 again equals 24. I don't have a variable. Now, is this the same as the last one? No. 21 does not equal 24. False. No solution. Alright. Now, what we have left is 4 word problems. I'm going to stop the video here. I want you to go and see if you can just do these on the practice sheet. Alright, get up, move around, run, get a drink, whatever you need to do, and then we'll tackle the word problems afterwards. Thanks for listening.